before we get into the discussion of how exactly we should systematically do pipelining, right, let us look at an example of what we mean by a time invariant system, right, because one of the constraints that is required for pipelining to be applicable in a scenario is that the individual modules that are performing computations need to be time invariant. Their functionality should not change with time, right. In other words, supposing a computation that we are doing as y of n is some function of x of n, and I replace x of n with some other x prime of n, right, not exactly with x prime of n, with some x of n minus k, the question is what happens as a result, right, what do I get on the y output, okay, and the requirement is that I should essentially end up getting y of n minus k, okay. So it's easiest to understand what we mean over here by taking a counter example, a case where this condition is not satisfied. Supposing y of n is a function n times x of n. What that basically means is there is a multiplication module whose input is the sequence x of n. Another input to that same multiplication module is n itself, okay. It's a measure of the instantaneous time. It is some counter that's keeping track of time. That is what is given as the input, and what we get over here is y of n, okay. Now if I replace x of n by x of n minus 1, right, what I am actually effectively saying over here is that this input to the multiplier, right, is going to be replaced by a delayed version. I have x of n, and over here I have x of n minus 1, but otherwise the multiplier, the other input remains the same, it is n, that does not change to n minus 1, because I have inserted a delay only on the branch involving x of n. These two are clearly not the same, okay, and this is an example of a case where essentially this pipelining is not possible, okay. In other words, this n times x of n is one particular example of something which is not time invariant. The value of n itself is used as one of the inputs to the multiplier, as the coefficient over there, okay, which means that as time goes on, the actual value which is used for multiplying the x of n is dependent on that particular value of time itself, okay. So there are certain examples of this sort where you can see that pipelining will not work. The simplest way of looking at it is, as long as the inputs themselves to your individual computational modules are time invariant, right. So what it means is that if I have a computational module which has some inputs, let us say x1 of n, x2 of n, and it has some outputs y1 of n, y2 of n, right. As long as I can introduce delaying the inputs, right, if this is what I have done, right, I get some outputs, right. In this case, as long as what I am going to get is y1 of n minus 1 and y2 of n minus 1, then this is essentially an acceptable transformation. In general, for a lot of cases, especially for signal processing type of applications, this is true. So it's not something very difficult to manage, okay. So for example, adders, right, as long as I am adding two inputs that can change with time, but are themselves not dependent on the value of the time variable, so to say, right. In other words, if I shift my entire sequence by one time unit, delay it, all that will happen is the output will also get delayed by the same time unit, okay. If that is the case, then this kind of pipelining, right, inserting a register at some point is acceptable.